Okay, today we talked about how we could graph motion. Our first illustration was simply an object or a person standing 2 meters away from the origin. And over a period of 5 seconds, the person didn't move. So when I'm thinking about that position, over a 5-second time interval, their position stayed the same. Now, if I think about the kind of line this is a horizontal line. Horizontal lines have a slope of 0. And when I think about the units for my slope, when I look at change in y over change in x, I get a unit of meters per second. Well, meters per second is the unit for velocity. So my slope on a position time graph is actually equal to velocity. So if I would then try to transpose that information and make a velocity time graph, since the slope is 0 over a period of 5 seconds, on my velocity time graph, I would simply have a line on the x-axis at a velocity value of 0 for 5 seconds. Well, this line also has a slope of 0. But when I look at the units for this slope, I've got a meter per second over second, which translates to meters per second squared, which is a value for acceleration. So, moving on to my acceleration time curve for this person that's standing still, I'm going to have another horizontal line on the x-axis for the first 5 seconds. So that would be what my position, velocity, and acceleration time graphs would look like for a person standing 2 meters away from the origin, or the starting point, and they don't move. Okay, next example, we were looking at a person walking away from the origin at a constant rate, and then after the first 5 seconds, they turned around and walked back to where they started. So, and I can tell they walked back to where they started just by looking at where the start and end points are on this graph. They're at the same place, they're at 0. So, walking away for 5 seconds from our origin, we ended up being 5 meters away. So, when I think about this slope, this is a slope of 1 meter per second. And then I turned around and I went back to where I started. That took me 5 more seconds. But now my slope this time is going to be negative because I changed direction. So graphing that on my velocity time graph, over the first 5 seconds, I have a value of positive 1. And the second 5 seconds, I have a value of negative 1. So notice part of my trip is above the x-axis, part of it is below. But the slope of both of these lines is still 0, which means I have 0 acceleration. So my acceleration time graph will still be, the 10 seconds will be on the x-axis. Now, let's look at an object that is increasing in speed. So if the object is increasing in speed, that means when I look at these equal time intervals, I'm going to see the object moving a further distance. Well, this is going to result in a graph that's going to have somewhat of a curve to it. Now, let's take a look at a little closer look at this particular. So I've enlarged it because I can't find the slope of a curved line. So what I have to do is I have to determine the instantaneous velocity. And the way that we do that is by looking at tangent lines. Now, what is a tangent line, you may ask? Well, if we have something that's curved, let's say like a circle, and I pick one point on that circle, and I draw a line so that it just touches that circle in one point, that line is a tangent line because it has only one point in common with the circle. So that's what we do here. At the different time intervals, let's say at 1, at that particular point we would draw a tangent line. Then at 2 seconds, the point on the curve here, we would draw a tangent line. And 3, I would draw another tangent line. And we probably can see just after these 3 lines that these lines are getting steeper. So they are going to be increasing in value. So that means my velocity at each one of these time intervals is going to keep getting bigger and bigger. So, for example, if at the 1 second mark my velocity was 2 meters per second, determined by the slope of this line, and then maybe I found the slope of this line, and it was 4 meters per second. The next line was 6 meters per second, and so on and so on. Because we're dealing with uniform acceleration, which means that our velocity should increase at a constant rate. So my velocity is increasing 2 meters per second for every second that the object is in motion. So when that translates to a velocity time graph, we end up with velocity time graph with a straight line. In this case, the slope is 2 meters per second squared, which means on my acceleration time graph, instead of my line being on the x-axis and lying at 0, now I actually have a value to acceleration. My acceleration value is 2.